surface that you see on all Weber products.
The coating on each kettle is quality checked in a room with lighting approximating daylight. Next, in the packaging area, handles and dampers are attached to the kettles, which then are packaged with all the other necessary parts for shipment to destinations around the world. After more than 50 years, the Weber kettle is still a big seller in what has become a very competitive marketplace, exploding with alternative designs and endless new options to choose from. The one burning question facing every backyard chef is which fuel to choose. Will it pour from a bag or come hissing out of a tank? The original and the most basic barbecue fuel is wood, especially if the goal is to add a real smoked flavor. But logs, along with the jumbo equipment to burn them, aren't always practical for the home barbecuer. One alternative is the wood pellet. The Traeger pellet mill in Mount Angel, Oregon begins its production process with sawdust from local furniture manufacturers.
The material is brought in from the top here, comes down, goes through what we call a conditioner that blends it together, and it comes down and is dropped down into the die. And we'll go ahead and open the door here so you can take a look. And as you can see, the material comes out here and drops down and goes in the center of the die. Inside the die, there's two rolls. This die turns, and the rolls force the material out through the die. This die gets up to about 400 degrees, and there's lignins that are in the wood, and the lignins turn to a liquid. It's like a glue. So when they come out, these pellets are about 400 degrees, and they're kind of soft. But the lignin, the glue, is what keeps them together.
After being extruded and cut into pellets, the material is carried off on a conveyor to be cooled and bagged. A few miles away, in a 100-year-old former dairy building, Traeger Industries also produces its own line of grills. Inside each of them is an electrically powered system developed to efficiently burn pellets.
The first component on it is a 1.5 RPM motor that drives the auger, which feeds the pellets from the hopper down to the fire pot. On the bottom of the fire pot, there's an igniter. When the burner is turned on, the element heats up and then catches the pellets on fire.
1 pound of pellets outputs 8,500 BTUs and can last up to an hour or more. The ability to add more pellets to the hopper as needed makes this an efficient way to maintain consistent heat over the long process of real barbecue. The more traditional way to cook barbecue is with charcoal. Charcoal is produced by burning wood until water vapor and other materials are removed, reducing the wood to almost pure carbon. Workers outside of Jackie Heights restaurant in Leesville, South Carolina, use a firebox to produce a steady supply of coals. The firebox feeds heat to the restaurant's pits for the entire time the hogs are being cooked.
This is the way you burn down real wood to get charcoal to put in your pits. It's real charcoal. It's not imitation.
Workers carry shovel loads into the pits as needed to maintain the temperature. They're spread around the edges to create indirect heat. The cooking temperature is kept so low that cardboard can be used to cover the pits.
You couldn't use cardboard if you get them any hotter than we do. We fire these hogs. In the wintertime, we have to go every 20 or 25 minutes. In the summer, usually every 30 minutes, if you put the right amount of coal to your shovel.
While Jackie Height prefers to burn down his own coals, most of us let others do the hard work and buy them in a bag. When mass-produced for commercial distribution, charcoal made from 100% wood is called lump. But for about 80 years, briquettes have been the most popular way to cook over coals, thanks to automaker Henry Ford.
It started back in 1922. Henry Ford was the originator. He was looking for something to do with the excess wood he had from making the Model T. Ford learned that he could take this excess wood and make briquettes out of it. The original plant was designed by two prominent people, E.G. Kingsford, who is a relative of Henry Ford and who the brand is named after today, and Thomas Edison.
Today, the Kingsford Company uses more than 1 million tons of waste wood each year. One of their plants, located in Springfield, Oregon, receives several daily truckloads of waste from local lumber mills. Each truck's entire trailer is lifted until its contents are poured out and added to the enormous wood pile.
After the product is dumped, we have a bulldozer where what we do is make it into a consistent pile. Since we get it from different mills in the area, the wood can be slightly different from mill to mill. This is what the material looks like as we get it in from the trucks, and you can see the particle size in it. It does have quite a bit of moisture to it. And we put this on the pile and age it for approximately 6 to 8 weeks. It's very similar to what you might have at home as a compost pile. This material is actually being seasoned in the pile, and so it does give off some heat, so you'll see some steam coming up off of the pile.
A bulldozer is also used to push the aged material into a hopper that feeds a conveyor belt. From here, it's a quick ride up to a shaker screen that sizes the material. The pieces that are small enough fall through holes in the screen, while the oversized pieces, which fall off the end of the screen, are ground down to the right size and added back to the process. Next, the still damp material is fed into a dryer.
And what this is very similar to what your clothes dryer might be at home. We're actually putting the wet material, the wet wood material is in feeding on this side of the dryer, where it starts out at 60% moisture and ends up at the end of the process at 5 to 7% moisture.
Then the dried material is fed into the top of a large kiln-like chamber called a retort. As the wood material travels from top to bottom, it's exposed to temperatures that surpass 1,400 degrees Fahrenheit. On each level, 4 slowly rotating ravel arms act as rakes to make sure the material burns evenly and to push it on to the next level. By the time it reaches the bottom, the wood has been converted into char. The char is then mixed with coal, other ingredients, and binders to hold the mixture together. At this point, the material has the consistency of a moist potting soil.
What is occurring here is the mixture, the char and the coal mixture that we're feeding together is actually feeding down in between these two press rolls. This facility makes over 3.8 billion briquettes a year through these presses.
After the briquettes are pressed, they travel over another shaker that eliminates any that are broken. Then it's on to the final drying process.
The 2 dryers that you see on either side of you stretch 120 feet long. A briquette starts at 26% moisture. It takes 1 hour and 40 minutes to go from one end of the dryer to the other end of the dryer, where it exits at 5% moisture. These briquettes that we produce can be packaged at the end of this time directly into a bag.
At Kingsford's Springfield plant, more than 110,000 tons of briquettes are bagged each year. The barbecue purist may see the briquette as a compromise to convenience. But an even greater compromise to even more convenience is gas. For the last few years, gas grill sales have outpaced charcoal grills. Fueled by a propane tank or a connection to a natural gas line, these grills are ready to cook in a very short time, and their temperatures can be controlled with a turn of a knob. Multiple gas burners allow backyard chefs to cook at different temperatures at the same time. To avoid the flare-ups that often plague gas grills, many create a more indirect heat with a layer of ceramic briquettes or tiles that separates the flames from the food. One technological step beyond gas burners are infrared elements. Thermal Engineering Corporation, or TEC, in Columbia, South Carolina, originally developed infrared for applications like paint drying. TEC first adapted infrared for cooking in the 1980s. Now they're manufacturing grills featuring a newly designed infrared emitter. Beneath the grill rack is a plate of tempered glass that lies over a perforated metal plate designed to emit a mixture of gas and air evenly over its surface. When ignited, the glass plate blocks the flow of hot air so that the food isn't cooked by convection, but rather molecular excitation. Infrared is a form of electromagnetic radiation with wavelengths longer than visible light, but shorter than microwaves.
These apertures are heated up to about 1650 or 1700 degrees, and then we use glass on top of this as a secondary emitter. The family of wavelengths coming directly off of this burner is shorter, and once they go through the glass or re-radiated by the glass, they become longer in the electromagnetic spectrum. And what our studies have shown is that if we use long wavelength radiation, we have less moisture loss and less shrinkage to the food.
But when it comes to barbecue, whether cooking with high-tech infrared or low-tech coals, heat and meat are only half the story. For many, the other half is all about sauce, sauce, and more sauce. Barbecue is about flavors, adding mouth-watering and savory tastes, using a rub as the hands-on way to spice things up. But the wet and sometimes wild way most of us do it is with a generous slathering of sauce. The majority of sauces are sweet and tomato-based. But in the Carolinas, mustard and vinegar are the key ingredients. The Southwestern approach is to turn up the heat with chili powder and peppers that range from searing jalapenos to hellishly hot habaneros.
Over the years, they've added a vast array of sauces. There's many different types of raspberry sauces, chipotle sauces, vinegar-based sauces, leading to the names of Whoop-Ass, Gates, John Henry's.
John Henry's first hit the shelves in 1996. And despite its growing nationwide distribution, it's still a small family-run operation in Houston, Texas.
We started out with 1 gallon of barbecue sauce with one customer. We took care of that one customer, made sure that one customer was always happy. We're around now, oh gosh, 1,000 gallons of barbecue sauce, a year.
John Henry sauces are made in a cramped kitchen, 40 gallons at a time, in a double-jacketed steam kettle. The main advantage of using this piece of equipment is that it protects its contents from scorching. A gas flame is used to heat water enclosed in a chamber beneath the kettle, which makes steam that circulates in the space between the kettle and the outer jacket, creating an even heat, perfect for cooking up a sauce.
To begin one of our sauces, we start with, of course, water, and then we start with the base of the sauce, which is called a slurry. And that is to give the sauce flavor, give it fullness,